It's my pleasure to introduce our speaker tonight, Dr. Todd Surovell. He's a professor and department head at the University of Wyoming and anthropology department. He's worked there for 17 years. He's the former director of the George Frisson Institute of Archaeology and Anthropology. He was born in Virginia, got his bachelor's at the University of Wisconsin-Madison, and then his master's and PhD at the University of Arizona. He's an archaeologist with specialization in the Paleo-Indian period, the first period of New World archaeology. He's an expert in stone tool technology, the human colonization of the New World, and Pleistocene extinctions. He's the author of one book and over 50 published articles. His major research efforts include the excavation of the almost 13,000-year-old Barger Gulch site, a Folsom campsite in Middle Park, Colorado, and the Duca Ethno-Archaeological Project, a study of nomadic reindeer herders in Mongolia. He's participated in archaeological fieldwork in Israel and Denmark, as well as the Western United States. Currently, he's excavating sites in Converse County, Wyoming, a Mammoth site and the La Prella site as well. So please join me in welcoming Dr. Todd Surovell, and I'm sure an incredible presentation.
All right, yeah, so today I want to talk to you, and thank you for having me, by the way. It's really interesting times, interesting to be in Maine talking to people in Jackson Hole. I actually really like to be in Jackson right now. It's a beautiful place. And I'll try to do my best to incorporate some geology into this talk for you guys. But today I want to talk about one of my favorite subjects, which is mammoths. Mammoths in and of themselves don't really interest me as much as their interaction with people. And in Wyoming, we have this really interesting pattern where the first people in the state correspond with the last of the mammoths. And I want to begin this talk. This talk is sort of as an unusual organization, and it starts in a strange place. It's a long and winding road. But I want to begin in June of 2014 when I was teaching our archaeological field school. We arrived in Converse County, and a day in June it was raining and we couldn't set up camp, so we took the students into town to the Pioneer Museum in Douglas. And there's a million cases in there, and this particular case drew my attention because it had mammoth bones, and we were in Converse County to dig a mammoth site. So I was really instantly curious about where these bones came from. We call this particular mammoth the Bishop Mammoth. And I want to organize this talk around three simple questions, simple at the surface, but we'll dive in deeply to all of them. One, how did these bones get there? Two, where did they come from, or where were they initially found? And then three, why do I care? I mean, you can go into any museum and there are lots and lots of objects, but these particular objects are ones that drew my attention. And in fact, I spent the next 4 years trying to figure out the origins of these bones. And I want to tell you that story while telling you a larger scientific narrative about mammoths and humans in Wyoming. So first, what is a mammoth? You all are geologists, you know the answer to this question. Mammoths are extinct mammals in the order Proboscidea, the order of mammals that includes elephants. In the New World, we had three genera of Proboscidea: the mammoths and the mastodons and the gomphotheres. You're probably familiar with mammoths and mastodons. Mammoths are more common in the West. Mastodons are more common where I am in Eastern North America. And gomphotheres really pick up once you get down into Mexico, Central and South America. Mammoths were huge, an adult Columbian mammoth. And in the New World, we had two species of mammoth. We had the woolly mammoths in Alaska above the ice sheets and against the ice sheets and along in the Great Lakes area. But in most of North America, we had Columbian mammoths, which are larger than African elephants. A big bull Columbian mammoth would have weighed about 10 tons. So this is an extremely large animal. Mammoths first arrived in North America about 1.8 million years ago. They arrived here the same way humans did. They crossed the Bering Land Bridge from Asia. Mastodons and gomphotheres have a much longer history in the Americas, having been here for at least 10 million years or so. Don't ask me about the exact history of those animals because my knowledge of the past as an archaeologist gets murky before about 2 million years ago. Today, proboscideans, as you know, have a very limited geographic distribution, and this sort of really cartoony distribution of proboscideans on the planet today. There are three species: the African savanna elephant and the African forest elephant, and then in South and Southeast Asia, the Asian elephant. Those distributions that you see on this map are highly idealized. As a matter of fact, in reality, they're much more fragmented as elephant populations are impacted by human activities like logging and agriculture and human settlement. So, for example, if we zoom in on the distribution of Asian elephants, you see it's highly fragmented today. What's interesting, though, if we go back 2 million years ago, elephants and their relatives were all over the planet, everywhere they could get to without a serious swim. They were throughout Africa, they were throughout Eurasia, and they were throughout the Americas. They had a much broader geographic distribution, and they were much more diverse taxonomically. And in that sense, you might think, as geologists, you guys wouldn't think this, but lay people would, that it seems unusual to find elephant bones in Wyoming, but in fact, elephant bones can be found in the fossil record in most places. There's nothing terribly unusual about it. It's really the absence of elephants in many parts of the world that's unusual today. Where can elephants live? Well, they can really live anywhere. Maybe the more interesting question is, where can't they live? In the top left, you see there elephants in tropical forests, where they are perfectly happy in Africa and in Southeast Asia. The top right, you see elephants in the Namib Desert in Western Africa, Southwest Africa. Savanna elephants in the grasslands, they're perfectly happy. And of course, you see there a young Asian elephant in the snow. Woolly mammoths, famous for being found in mummified remains in Siberia and Alaska above the Arctic Circle. Large body size really allows adaptive flexibility. It allows you to conserve water in dry places. It allows you to be cool in warm places. It allows you to be warm in hot places. And this is why we see elephants throughout the world in the fossil record, which makes their absence really interesting today. And I'm gonna come back to that in a second. So, in the most basic sense, how did the elephant bones get to this museum case in Douglas, Wyoming? Well, sometime within the last 2 million years, we know that because they're mammoth bones. A mammoth died near Douglas, Wyoming, and somebody found them and donated to the museum. So the first clue I had in terms of trying to figure out where they came from were the clues from the display case itself. This is the sign that was in that display case. And it says, "Mammoth excavated from Bedtick Creek, south of Douglas. The site was discovered by Dr. Byrd of the American Museum, and it was a gift of W.R. Eastman." So there's a nice locational clue there. It says it's from Bedtick Creek. This is a tributary of the North Platte River, about 6 kilometers south of Douglas. It flows for about 14 kilometers from west to east, draining a small mountain in the area called Sheep Mountain. That's not a very good clue if I wanted to find the exact location that mammoth came from. It's a fairly big area. On top of that, the year I learned about the Bishop Mammoth, and this is the reason why I call it the Bishop Mammoth, was that the director of the Pioneer Museum at the time, Arlene Eklund Erst, had a letter that was in their archives relating to the discovery of these mammoth bones. And she gave me this letter. It was written by Lauren Bishop, or L.C. Bishop, who was the Converse County surveyor and later the state engineer for the state of Wyoming. And this is a letter written in June 21 of 1958 to the state geologist, Horace Thomas. And I'm going to read you a few excerpts from that letter. Remember, this is 1958. He says, "About 20 years ago, a friend and I dug out the head bones and huge teeth and the 2 front leg bones from the base of a bank on land then owned by me. The bones are about 9 feet below the surface in a soil that's rather heavy and well compacted. Geologically, it's where the Dakota sandstone is joined in the northwest quarter of section 1, township 31 north, range 71 west, by either the White River Formation or just plain gumbo soil." There's a nice geologic clue, right? And a very specific geographic location, giving a quarter section. Then he says, after about July 8th, I'll be free to go to Douglas and assist in the supervision if Mr. McGrew will be available to get us going at that time. So what Bishop is doing here, he's writing to Horace Thomas and he's looking for professional help to excavate the rest of this animal, which he found 20 years earlier. The bones he describes are the bones that are in that case. In fact, the bones are a humerus and an ulna and the mandible and a molar. And I was very confident this was referring to the mammoth that we're talking about, and it provides some great locational clues. Except there were contradictions. Signage in the Pioneer Museum says that Dr. Byrd of the American Museum found it, but Bishop's letter says that he found it. The quarter section identified by Bishop is 6 kilometers from Bedtick Creek. It's not in that drainage at all. It doesn't have any sandstone, like he says, and in fact, that land was never owned by Bishop, even though he says he owned the land where it was found. So it was not terribly helpful after all. We used this letter to try to find that animal, to try to find the original find location in July of 2018. Why did I do that? Why would I spend so much effort trying to track down the find location of a fossil mammoth? After all, thousands of fossil mammoths have been found in North America. Well, I'm an archaeologist, right? It's not the mammoths that interest me as much as interactions between humans and mammoths. And really what I'm interested in is ecological, economic, and social aspects of these interactions. And humans and proboscideans have been having interactions for a long time. What you're seeing here is a painting in manganese dioxide in a cave in France called Rouffignac, an Upper Paleolithic depiction of a woolly mammoth. The extinct Pleistocene fauna are fascinating, that these are things that we actually have human depictions of. And humans were interacting with mammoths well before the Upper Paleolithic. We don't know the age of this particular painting. It's got to be between probably 20,000 and 40,000 years old in France. But the interaction between humans and even our hominin ancestors and proboscideans goes back much, much farther than this. The earliest evidence that we have for human interactions with elephant relatives goes back to the earliest members of our genus. This is Homo ergaster, also known as Homo erectus, or African Homo erectus. This is the early hominin species, walked on 2 feet, had the stature of a modern human. Some people think Homo ergaster were the first hunting hominins. That's debated. But in Olduvai Gorge in Tanzania, East Africa, beginning 1.7 million years ago, we see the beginnings of this phenomenon, where here you see the bones of an Elephas rechi associated with a scatter of stone tools. Hominins were clearly interacting with this animal. Whether they hunted it and killed it or were scavenging it and butchering it, we don't know. But these kinds of sites have a deep, deep history in the archaeological record. And it continues. There's another site from Germany from 120,000 years ago, from the last interglacial, the last warm period before the last glaciation. This is the site of Groburn. This is the Elephas antiquus, or straight-tusked elephant, extinct species of proboscidean, tightly associated with stone tools. No doubt this was associated with Neanderthals. The story continues into the Upper Paleolithic and modern humans, Homo sapiens sapiens. Here you see a woolly mammoth rib with a stone tool embedded in that rib. This is from the site of Krakow in southern Poland. And of course, this pattern continues into the New World. This site is 13,000 years old from southeastern Arizona, from the San Pedro River Valley. This is called the Laner site, and this is a Colombian rib cage of a Colombian mammoth. And at the tip of that trowel, you can see a spear point that was used to kill that animal. If we look at this biogeographically, I think there's a really stunning pattern. So this shows the distribution of proboscideans 1.8 million years ago in the top left, and then on the bottom today. What if we look at the distribution of the genus Homo, our genus? This is where we were 1.8 million years ago. There were members of our genus occupying portions of sub-Saharan Africa. and had finally made it out into Eurasia and were found in the lower latitudes of Eurasia, particularly into Southeast Asia. In fact, the distribution of hominins 1.8 million years ago mimics quite a bit the distribution of proboscideans today. Interestingly, though, if we look at the distribution of Homo today, we're global, right? And proboscideans are dramatically reduced, where we've basically replaced them in space over this time period. And in fact, if we look at this pattern globally of human exploitation of these animals, or at least these sites where we have proboscidean remains and clear human interaction with them, you see a very, very clear pattern. So this just shows a time-space sequence where the oldest sites where we see interaction with proboscideans are in Africa and the southern latitudes of Eurasia. And as we go through time, we see evidence for this phenomenon sweeping through higher latitudes of Eurasia and eventually into the New World. And this speaks to a very clear pattern where people are slowly colonizing the globe over the course of the Paleolithic. Once they get into the New World, they very rapidly move through their New World. But in every case where we see hunting of these animals is really concentrated on the edges of the human range. As humans expand across the globe and we move into the ranges of proboscidean taxa, that's where we see archaeological evidence of it. The big anomaly to this, of course, is the survival of elephants today in Africa and Asia. And we can talk about that if you have questions about that. So in the New World, this pattern has been known for a long time, that the arrival of the first humans correlates with the last of the Pleistocene megafauna, meaning, you guys know what Pleistocene megafauna means, Ice Age large animals, right? And this is a very famous photograph from the San Pedro Valley of Arizona, showing a very famous geologic deposit. That black stratigraphic level there is known as the black mat. It's essentially a cienega or a marsh soil. That black is organic matter. And beneath it, you can see a mammoth tooth. And at this stratigraphic contact dates from about 12,700 to 13,100 BP. Beneath that stratigraphic contact, we have lots of Pleistocene megafauna and no evidence for humans. That's my opinion. This is a topic we still debate about, the exact timing of arrival to humans, to the New World. But if we're going to paint this with a broad brush, beneath the stratigraphic contact, we have these animals and no artifacts, no evidence of humans. Above it, we have lots of evidence of humans and no more Pleistocene megafauna. The mammoths are gone. So what you're seeing here is one of the last mammoths to walk in the New World. And at that contact is where we find both of these things together. And it's for a very, very short time period where we see interaction of humans with these extinct animals. Humans crossed the Bering Land Bridge from Northeast Asia around, I would say, 14,500 years ago. They arrived in eastern Beringia. They walked across the Bering Land Bridge, of course, and in eastern Beringia, you had tundra, but the way south was blocked by the continental ice sheets, the Laurentide ice sheet in the east and the Cordilleran ice sheet in the west. Eventually, with the warming of the climate, global climate, at the end of the Pleistocene, humans made their way south into the glacier, through the glaciers. The exact route we debate about whether it was in a corridor between them, along the coast, or both. But by about 13,200 years ago, everybody agrees we had humans south of the ice sheets in North America. And very quickly, or at least in a very narrow time window, this period from 13,100 to 12,700 BP, we see evidence of the exploitation of proboscideans across North America and into South America. This is associated with spear points that we call Clovis points that you see on the upper right. Those particular Clovis points are ones I photographed in Sonora, Mexico. But if you found them in Wyoming, you couldn't tell the difference. I mean, they're absolutely identical across this entire space. And the map there shows the spatial distribution of elephant kill sites that we have in North America. Most of those are kill sites of mammoth. One is of mastodon, the one in Missouri here, that's the Kemswick site, and the one down here in Mexico in Sonora, that's a Gomphothere kill site called Fin del Mundo. And in Wyoming, of course, we have a very famous Clovis kill site called the Colby site, excavated by George Frizen. This is just east of the town of Worland in the Bighorn Basin, where Doc Frizen found, this is Doc here, you can see his knees poking out from behind this giant pile of mammoth bones. In fact, he thought that pile was cultural. It's not a natural arrangement of bone. He thought it was actually, after killing this animal, people piled up the meat and froze it, and it was essentially a frozen meat cache. But at this site in Wyoming, you have about 8 mammoths, 3 Clovis points. That's one of them that you see there, and a handful of about 35 small flakes from resharpening butchery tools. So this Wyoming site, the Colby site, is one small um, piece of a global phenomenon. And of course, Pleistocene extinctions, when I say Pleistocene megafauna, we're not just talking about the elephants. Certainly the mammoths and the mastodons and the Gomphotherium go extinct around 12,800 to 12,700 years ago, but they weren't alone. There was a huge mass extinction event that affected our continent at that time. In fact, both continents, North and South America, and the extinctions in South America were even more severe. These extinctions were highly size selective, preferentially affecting the largest animals around. If you were in Wyoming 15,000 years ago, you would have seen elephants, you would have seen camels and horses and giant short-faced bears, American lions, American cheetahs. If you were down in Texas, you could have seen Gomphotheriums, which are armadillos that are often compared to Volkswagen Beetles in size. If you were in this part of the world where I am, there were giant beavers the size of black bears. The carnivore guild was incredibly impressive. There were saber-toothed cats, multiple taxa, that lions, dire wolves. And this extinction event seems to have been very sudden and post-dates human arrival. Oh, and of course, the giant ground sloths. Interestingly, there are giant ground sloth fossils from virtually all of North America and every state surrounding Wyoming, but nobody's ever found one in Wyoming. That's a kind of a biogeographic mystery to me because they're very commonly found in caves and rock shelters, and we have plenty of those. So why do I care about this particular mammoth? Well, because it's possible that humans killed this mammoth. If it was just a mammoth that died naturally, I'll leave that to the geologists. I'll leave that to the paleontologists. You guys can have it. But if this is an animal that people killed and it's an archaeological site, these are incredibly rare things. From all of North America now, we have 15 sites that show human interaction with mammoths and mastodons, and we've been doing archaeology for over a century now. So they're really, really rare sites. So could this have been an archaeological mammoth? Well, and obviously the difference is, are there artifacts associated with it? So the Colby mammoth is an archaeological site. The Marquette mammoth, one that was recently found up at Buffalo Bill Cody Reservoir, I think, outside of Cody, Wyoming, is a paleontological mammoth. There's no archaeology associated with it. One way we could tell, perhaps, if the Bishop mammoth, at least one clue that would help us make that decision, is it archaeological or paleontological, is to date it. How old is it? If it predates human arrival on the continent, I'm not interested. If it produced a radiocarbon date of 40,000 or something, I wouldn't be interested. So we got permission from the new director of the museum to sample the humerus. Here I am with my safety goggles on, cutting a chunk out of that humerus to get a date on it. Remember, the Clovis period dates from 13,100 to 12,700 years ago, and mammoth extinction in Wyoming dates to about 12,700 BP. So we sent in a sample for dating, and it dates to exactly what I wanted it to date to, between 12,700 and 12,850 BP. This was one of those mammoths that humans could have interacted with. It died when humans were in the state of Wyoming. It made it a lot more interesting to me. And I felt a lot more urgency to figure out where it came from so we could go to that site and try to identify if there was evidence for archaeological activity, if there is evidence for human activity there. It's a Clovis age mammoth, and it dates close to the extinction event. In May of 2018, I was back at the Pioneer Museum, and we were poking around in the basement, and we found this paper bag with these bones in it, and written on this bag, typed on this bag, was something really interesting. The date of July 16, 1958. It says, bone fragments taken from the location of the mammoth of the elephant family, of which we have the leg, jaw, and 2 vertebrae now in the museum, dug out by Bishop, Hildebrand, and Vetter on July 15th, 1958. So if you remember the letter that Bishop had sent to Horace Thomas, uh, it was dated June 1958, and he said he was going to go out there and dig up the rest of the mammoth. And here was this paper bag that showed us that he had gone back out there. In the bag were these 3 bones. I thought, is that all that he collected? But sadly, this bag was sitting in a crate, and beneath it in that crate were these bones, which are clearly mammoth bones. They're not labeled, so we didn't know, were these bones, did Bishop go out there and dig out the whole mammoth and this is what's left? We had no idea how these related to what was in that bag, but we knew Bishop had gone back out there. So given the clues I had from Bishop's letter, really I was believing Bishop's letter more than I was believing the signage in the museum. In fact, I tried to figure out who Dr. Byrd was. We looked at correspondence with the American Museum of Natural History. In fact, they sent somebody out from New York City to look at this mammoth when it was in the ground in 1938. The guy who looked at it didn't discover it, and they weren't interested because they didn't think it would be enough of the animal to mount in their museum. So Bishop had definitely found it. Given the information we had, this is the location we went to study. So basically what I was doing was, I was looking at the map and I was trying to find land that Bishop owned, and I was looking for that particular quarter section. I think it was the southwest quarter of land that Bishop owned at the time that had a sandstone formation on it, preferably Dakota, but I'll take any sandstone I can get. It has potentially a 9-foot cut bank. And all of those things seem to come together in this location, this unnamed draw in Converse County. So I went out there with a few students in July of 2018, looking for a needle in a haystack. So, and did somebody pull a mammoth out of here 60 years earlier somewhere? And how would you try to figure out where that is? This is a really long draw that goes for about half a mile. So we went out there, and really what we did was we looked for Pleistocene deposits. We were just looking for sediments of the right age that could preserve mammoth bones. And the first thing we did was augering. So we used a bucket auger. You guys probably know what that is. It's basically a way of drilling down in the ground so we can get a stratigraphic section and collect samples for dating and get an idea of the alluvial stratigraphy in the area. And this just shows the time-lapse movie of us augering and pulling out sediments and recording there the stratigraphy, the sediments, the soils, and the stratigraphy. We're also collecting samples to date. We did this up and down this draw, and over a period of about 4 days, we had 1 extra day left, and we had basically figured out the geology. We didn't know how old anything was, but we knew where the oldest alluvial deposits were in this valley. So we decided to go for it. And because of that spot that I showed you in that aerial imagery, you can see the sandstone outcrop here, and Bishop described Dakota sandstone meeting White River Formation or gumbo soil. Here's a alluvial terrace. It's about 9 feet high. I thought, what the heck? Let's go for it. And I made my poor students dig a trench in 1 day in 90-degree heat with no shade that they named Todd's Torture Trench. And here's the time lapse of us digging this trench, trying to find a mammoth. We did this all in 1 day, dug this trench. We actually found in this trench buried archaeology. Now we're breaking for lunch. Come back, finish it. We found some buried artifacts in this. We profiled it. We collected samples for dating. But sadly, we found no mammoth bone. But we did find buried archaeology. And we had done a lot of work. And there's my students. I'm eternally grateful to them for helping me dig that. And I dug as well. So I tortured myself too. But we didn't know if we had found the spot. I mean, we certainly didn't find any mammoth bones. What we knew was we had this buried archaeological component. We found 5 artifacts, flakes, just chips from making stone tools. We collected samples for dating, but we found no mammoth bones. Nice stratigraphic section. So at this point, we just submit radiocarbon samples and wait and see, are we at least in the right ballpark? Are these sediments 13,000 years old? Could this deposit be near to the place where this mammoth was found? So we submitted those radiocarbon dates, and it takes a few months to get your dates back. And we had learned, in May that Bishop had been out there in 1958, and it occurred to us that that was 60 years prior, and it's possible that there was somebody still living who had maybe been out to the site in 1958. So we decided to reach out to the public. So I talked to Wyoming Public Media, and they had a nice story on the radio, and I talked to the university press office. And we had this story about, and here's this nice headline: Surovell seeks help in tracking down Mammoth site. We knew if it was 60 years before, if anybody had been there and they were still alive, they would have had to have been a child at the time. So this is the Douglas Budget's story. What really fascinates me about this time period and this idea of the first humans is that the first people to go anywhere, there aren't a lot of people in the history of our species who could have been the first to colonize an empty continent. And those people had opportunities unlike the rest of us will ever have, right? So from an anthropological perspective, it's a really, really interesting question. What would you do if you're the first person to step foot in Wyoming? Or if your family was the first, or your band of foragers was the first? And your options are really limitless. Where would you live? Where would you move to? Would you be nomadic? Would you be sedentary? Would you hunt large game? Would you use plant species? Would you have a very diverse, broad diet? Would you have a narrow diet? What would your social organization be like? Would you be egalitarian? Would you be a chieftain? Your options are limitless. And as an anthropologist, this is the question that really fascinates me about studying First Peoples. The Clovis complex, we argue about whether Clovis is first. I believe it was, if it wasn't first, it was very close to first. It's the first widespread recognizable evidence of humans in the New World. Clovis sites are really, really rare. We know that during the Clovis time, human population densities were very low. Clovis is named after Clovis points that you see there on the right, these large spear points that are fluted. They have these flakes removed from the base to give them that channeled appearance. And Clovis people are very often associated with hunting of large game. So all these Mammoth, Mastodon, and Gomphothere kill sites are associated with Clovis points in North America. And we know by looking at the movement of lithic raw materials in Clovis sites that they're extremely nomadic, moving their base camps regularly, covering huge distances. I'm fascinated by Clovis, and since 2014, I've had the opportunity to dig a Clovis site, the Laprelle Mammoth site that Mike mentioned in the introduction, and that's this site here. You're looking at Laprelle Creek. Our camp is at the very bottom of the screen. The site is at the top of the screen. This is a tributary of the North Platte, and you can see the North Platte in the background in the upper right, and the old railroad bridge of the Chicago Northwestern Rail Line, now defunct. And I'm just going to fly you over the site with our drone down the Laprelle Creek, and those are our excavations. The site is buried very deeply in alluvial deposits in the 7-meter high alluvial terrace, and deposits that are about 12,900 years old. So it's a challenge to dig. It requires a lot of earth moving to dig the site. And I just want to share with you a few of the things we've learned in excavating the site. The site was originally discovered in 1986, not by an archaeologist. Most of these sites are not found by archaeologists. It's found by a doctor from Douglas, Wyoming named Doc Heinrichs and his buddy Mike Ernst. They were out there hunting artifacts, looking for arrowheads, and they found mammoth bones poking out of that cut bank that you see there. Eventually, George Frizen, the state archaeologist and the department head at the University of Wyoming, my predecessor, learned about the site, and he put in a test excavation in 1987 and found mammoth remains associated with artifacts, but because of a dispute with the landowner at the time, the excavations were shut down and nothing happened for 27 years, except that bank eroded back a little bit. In 2014, we were finally able to go back in, and I was really excited to do so. And what we have at this site is a Clovis mammoth kill and campsite. This is what the bone bed looked like at the time that George excavated it, and what you see there is the midsection of a Columbian mammoth. What do you call it? The atlas vertebra just beneath the skull is on the bottom of the screen here in the south. You can see some articulated rib sections. The vertebral column kind of runs in this direction if you can see my mouse. It's more or less laid out in anatomical order, although the mammoth sat on the surface for a while before it was buried because its surfaces are pretty highly weathered. And you can see a stone tool in the top left that George Frizen found in and among these bones. He also found a small number of flakes from sharpening butchery tools in that bone bed as well. Since that time, we've excavated much, much larger areas of the site. So George's excavations are shown in the block A there George excavated a very small part of that. We've expanded our excavations to a much, much larger area, and we found some really, really interesting and unexpected things. In particular, that it's not just a mammoth kill, it's also a campsite. So I just want to show you a few of the things we found because it's a really, really unique site. I want to focus on this area here called Block B. This is about 12 meters south of the Mammoth, southeast. So about 36 feet away. We found it by accident because we found an artifact in the cut bank there. This is what our excavations there look like. And in our excavations, we found a big stain of red ochre being hematite. You guys know what hematite is, iron oxide mineral. And in the Pleistocene, North America, it's used as a pigment. It's essentially a paint, although it could have had some utilitarian purpose. Most people think it had a ritual use. We're not sure, but the ground was literally stained red with this stuff. There was so much of it dropped at the site. It's a hearth feature or a fire pit. Hundreds of flakes. Actually, in this area, the count is now up to about 1,500 flakes. Waste products from making and resharpening other tools. Several flake tools or implements that were used. We also have butchered bison bone and cooked bison bone in this area. We have several bone needles, which was a huge surprise. We did not expect to find evidence of sewing at a mammoth kill site. These are among the oldest bone needles from all of the Americas. And we also found a bone bead. And as far as I know, this is the oldest bead from the Americas, and we have it from this site in Wyoming. So this is the stain of red ochre here. So what you're looking at is our excavations. The deep hole here is our excavations from the previous year. And the nails here are 1 meter apart. That's our excavation grid. And you can see kind of light pink staining in the sediment there. That's hematite that was brought into the site. We can enhance this using software called D-Stretch that makes it show up a little better. That gives you a sense of how much hematite was dropped on the surface at this site. What people were doing with it at the site, why they carried so much of it around, why so much of it ended up on the ground, we just don't know. We've speculated about it a lot. If you have questions about it, we can talk about it, but a really, really interesting thing to find at a mammoth kill site. Stains like this have been found in a few other Paleo-Indian sites. They're also found in upper Paleolithic sites in Europe. Here's some of the flake tools. Oh, and I should note that ochre, that hematite, we've been able to source it geochemically, looking at trace elements. And since I'm speaking to geologists, we know exactly where it came from, pretty close to where it came from anyway. It's identical to the hematite you find at the Sunrise mine, and Sunrise, the now defunct iron mine in Sunrise, Wyoming. Interestingly, there's a big Paleo-Indian ochre mine associated with that historic iron mine. And that's where it came from. It's about 55 miles to the southeast, down the Platte River Valley. Most of the chip stone from the site comes from the same area. You can see this nice dendritic chert, and that's from the Hartville uplift from Guernsey and Hartville Formation. The brown translucent chert, I think, is probably Green River Formation. Interestingly, probably from Sweetwater County or possibly from Carbon County. So we have people coming into the site from different parts of the state. Here are the bone needles. These things are tiny. They're broken probably because we broke them in excavation. We find them in the screen because we screen with really, really fine mesh, essentially window screen. And you can see this one on the lower left, it broke across the eye. They're very flat in cross section near the eye, and then they're very round near the tip. Just to give you an idea of how small these are, here's a dime for scale. These are very, very delicate artifacts. And here's the bone bead we have. You can see it's got some incisions on it and stained with red ochre. That's because everything in that area was stained with red ochre. I don't think that's intentional. I think that just came off of the sediments. But it's really interesting to ask what is going on. Why do we have all this evidence of what's clearly sort of domestic activities right next to this mammoth? And our current interpretation is that, oh, and I should note one other thing, probably the most fun thing we found there. This was quite an accident. We were working in this Block B area, and we could see that artifact densities were trailing to the south. So we thought, oh, let's put in some test units to the south to see if anything continues down there. We put in a trench and then dug half a test unit, which is 0.5 meter by 1 meter. And right here, we found one artifact, which is an artifact I've been looking for 25 years, and now I can retire now that we found a Clovis point, beautiful Clovis point made on a red opaque chert, possibly Phosphoria formation for the bighorns, but I'm still trying to figure that out. So how we view that site is we use an analogy to recent foragers. So historically, anthropologists have observed elephant hunting in the Congo rainforest by Mbuti and other pygmy foragers. And when they kill an elephant, unlike when hunter-gatherers kill other animals, so typically, like if you kill an elk, you cut up the choice parts and you transport them back to your camp. But when you're talking about an elephant or a mammoth, the animal's simply too big to transport. So instead of moving the mammoth to your camp, you move your camp to the mammoth, and that's what we know that the Mbuti do when they kill an elephant. So they'll kill an elephant, they move their camp to it, and then they'll spend, everybody will move there, and then they'll spend a week or two processing that animal, drying the meat before they move on. And we think that's exactly what Laprelle represents, is they killed a mammoth and they moved their camp there. They spent a little bit of time and left. And we know they weren't there for long just because of the artifact densities aren't very high compared to other sites. So in Wyoming, we have the Colby mammoth. Now we have the Laprelle mammoth. And there's another site called the UP mammoth in Carbon County that is possibly another association with humans. It's debated because it's in very mucky spring deposits where artifacts have probably moved after the fact and possibly moved in association with a mammoth that was found in the bottom of that. So it's one we debate about. But we have, given there are only 15 of these in the New World, we're actually quite rich in these sites in Wyoming. Okay, so back to Bishop. Where were they found? Well, sitting there waiting for my radiocarbon dates, and on September 5th, 2018, I finally get an email from the University of Arizona, and I'm nervous about it, hoping that the dates are, around 13,000 BP. And I get the dates, and they're all way too young. The oldest date we had was about 3,300 BP, and the youngest is 2,200 BP. The archaeological site we found was a late archaic site. It was only about 11,000 years younger than what we were looking for. This was incredibly demoralizing. I had spent, 5 days out here with all my students looking for this mammoth, and we thought we'd identified the perfect location given the clues we had. And honestly, I had no idea where to go next. Thankfully, that's not the end of the story. 2 days later, in my inbox, I see this. Pat Neal. Greetings, Todd. I read with interest the article in the Douglas budget. I open up the email, and Pat says, it brought back memories of a time when I was about 12 years old. Our family was friends of the Hildebrands. My mom was an amateur geologist, rockhound, and we spent time exploring. As I remember, Lyle Hildebrand invited our family to accompany him and friends on a dig. We spent 2 long weekends on some property where we had found some remains of mammoth, and from what was found, a partial bone of a 3-toed horse. I know that much of the mammoth we were digging was left covered up because it was too delicate to remove, but the bones we collected, we took home and cleaned up on our backyard and then gave them to the Historical Museum at the Fairgrounds in Douglas. They may be the ones referred to in the article. Since I don't know the specific location you're looking at, this may not be of interest to you. I do know the discovery was in the bank of a creek bed. I'm certain I have many pictures of us digging at the location and of our backyard with the bones being cleaned. If you're interested, let me know, and I'll dig into my old photo album, scan the pictures, and send them to you. I was pretty excited. I emailed Pat. I said, Pat, what's your phone number? And I called Pat. Pat was a little taken aback by my enthusiasm. I was like, Pat, what do you remember? Do you remember anything? He's like, no, I was a kid. I was 12 years old. I was in the back of my mom's car. I said, do you remember like which way you went from Douglas? Did you go north? Did you go south? Do you remember anything? He's like, we used to go all over the place. I mean, I kind of remember seeing Laramie Peak, but I don't know. And I was like, Pat, when you get home, I'd love to see your photo. So Pat goes home, and I'm watching the Rockies play the Dodgers, and I start getting emails from Pat. Here's Pat, 12 years old, and here's a mammoth. And Pat, this is Pat today. Pat's an IT professional. He lives in Oregon. He grew up in Douglas. He happens to look at the Douglas budget website every now and then, and he happened to see this story. Um, and he starts sending me scans of these photographs. And I am really, really, really excited. Most of these photographs aren't super useful in terms of giving us locational clues, but it did answer my question. Those bones in that crate at the Pioneer Museum are absolutely from this mammoth. And you can see in the lower right, the bones cleaned up in Pat's yard. Those are the bones that ended up in that crate. But amazingly, there were two pictures of the 38 or so that he sent me. These two photos here, where you can see enough of the background where I was able to go out. I went out to Converse County as soon as I could, and I found this site on September 14th, 2018. And this shows the site today, actually. Well, that was 2 years ago. One of these on the guys with the shovel is Bishop. The other one is Lyle Hildebrand. They're standing on the same landform you can see here. In fact, if you look at the bends in the draw in 1958, you see that the draw has hardly changed at all in 60 years. It's pretty amazing. And I'll just note the way I was able to identify this location. If you guys can see my mouse, in this photo between Bishop and Hildebrand, there's a very distinct landform here. This is, I want to say, White River Formation. No vegetation on this hill. It's a very conical hill. And in the Douglas area, it's known as Target Hill because it was used for target practice in World War II. And you can see this draw with the cottonwoods down in it in 1958. Turns out that's Bedtick Creek. And by lining up those clues, we're able to walk right to the spot. I shouldn't say walk right to the spot. We wandered around that valley for a few hours until we found it. So pretty amazing story of discovery. So here's what I know about the Bishop Mammoth. It was originally found around 1938. In July and August of 1958, most of it was excavated by Bishop, Hildebrand, and Sims. These are locals. They aren't geologists or paleontologists, archaeologists. They're just interested in getting these mammoth bones for the museum. We believe some of the mammoth is in place. That's Pat's recollection, that it was too delicate to remove. In fact, I have a student doing an inventory of the mammoth bones right now. We got them from the museum. Pat remembers finding no artifacts, which may be significant, it may not be. If we weren't using very fine mesh screen in our excavations, we would have found about 3 artifacts in the huge excavation area we've dug. And we know this is a Clovis-aged animal, or it likely is. It's possible our date is wrong, but I feel really good about it. What I still don't know, what bones were recovered. I'll know that soon when my student finishes inventorying them. What bones are still there. I don't know if there's any human interaction with the mammoth, and I don't know how much of this deposit remains. But it's worth going out there and checking. And I've been in contact with the landowner, and the landowner has been supportive of us going out there. And in fact, we planned on going out there to test that site this summer, but of course I'm in Maine and you guys are watching me on your computers because we're all in the same situation. COVID has delayed all of our field work for a year, but we're really excited to go back out there. So to sum up, we had herds of mammoths roaming the plains of Wyoming and the mountains of Wyoming for almost 2 million years. Around 13,000 years ago, humans entered Wyoming's ecosystems and for a few centuries hunted these animals. And I'm quite confident that humans drove mammoths to extinction. If humans had never colonized this continent, mammoths would still be walking the continent today. This event in Wyoming was a small part of a global story spanning tens of thousands of years, and it was repeated over and over again in the course of human global colonization. As humans moved into new areas, they left proboscidean populations decimated, and elephants survive only in places of the world, and a few isolated places of the world today where the process continues. All right, that's my talk, and I'd be happy to entertain any questions you guys have.
Thank you very much, Todd. That was amazing. And our first question is, how do you tell what's the difference between a cooked bone and an uncooked bone?
It's a good question. I'm going to repeat the question because I have spectators. My uncle and aunt are here. They don't want to be on camera. I'm going to show you. There they are. Sorry, now I messed up my camera. The question was, how do you tell the difference between a cooked bone and an uncooked bone? So cooked bone, as most of you probably know, is a composite material. It's mostly made of rock, mineral apatite or hydroxyl apatite, calcium phosphate. But there's also organic matter in there, primarily the protein collagen. And when bone is cooked in a fire, there are changes to both the organic and the inorganic components. The inorganic component recrystallizes and becomes highly crystalline. It starts in a poorly crystalline phase. And the organic matter first becomes carbonized, it turns black, and if it's cooked hot enough, the organic matter is completely burned out of there and the bone turns bright white. So it's pretty simple to tell when a bone has been heated. There's certain things that can mimic that, but there are good ways to tell those apart.
Another question, my question, the Monteverde site in Chile has seemingly been dated at over 18,000 years. And can you discuss that?
Sure. So the question was, the Monteverde site in Chile has been dated to 18,000 BP. Monteverde is an interesting site. The most famous component of that site dates to 14,500 BP. That's called MV2. The MV1 component of that site dates to 33,000 BP. And the most recent stuff they found there, they argue, is about 20,000 years old. I guess what I would say regarding Monteverde is that a lot of archaeologists accept it as a legitimate site, but a lot of us don't. It still remains very controversial. So the classic component of Monteverde is a very, very well-preserved peat bog that has mastodon bones in it and really well-preserved organic matter. There's very little in the way of actual artifacts. Most of the things identified as cultural are things like modified wood and the interesting arrangements of wood. So I'm very skeptical about that site being cultural, and especially the older components remain as complete anomalies in the archaeological record. There are very few things that even approach that kind of age for North America. But I will note that the date of human arrival to the Americas remains something that's fiercely debated and highly contentious. I take a pretty conservative point of view on that. I think it was rather late, and I'm not convinced by the evidence at Monteverde at this point.
So next question is, why did the proboscideans survive in the areas first co-populated with hominids? In other words, did the coevolution of the genus Homo with existing elephant populations have something to do with their survival? I'm paraphrasing the question.
That's a great question. The question was, why do elephants survive today in the regions that humans first evolved in? So Paul Martin, who was sort of the champion of the overkill hypothesis, which is the idea that humans drove this extinction event, made that exact argument that it was a coevolutionary phenomenon, that those animals in those areas evolved with humans as humans became hunters and recognized humans as hunters. Whereas in other parts of the world, they were naive to humans as hunters, sort of like they are. You guys recognize this up in Yellowstone all the time, right? There's no fear of humans as hunters. So that's one hypothesis, is that in Southeast Asia and in Sub-Saharan Africa, as humans evolved the ability to hunt, elephants evolved with them. And there's no doubt some truth to that. I have always wondered if there's a biogeographic explanation. In general, when we look at the survival of megafauna and large mammals across the globe, to me, there's one single unifying phenomenon, and that is large animals survive in places where human population densities are low. And you can name any large animal, whether we're talking about bison in the plains, or caribou in the Arctic, or moose in the mountains, or elephants and rhinos in Sub-Saharan Africa and Southeast Asia. They generally exist in places where human population densities are really low. So for example, in the tropical forests of Africa, there's very little evidence for much human activity in there, at least high human population densities, until people started doing swidden agriculture, cutting down the forest, and growing crops in there. Before then, rainforests are actually terrible places for people to live. There's a lot of biomass, but very little of it is edible. So humans can't exist at high population densities. But to drive an extinction event, you have to reach critical population densities. So to me, I wonder if it's sort of a combination of an interesting phenomenon that we evolved from tropical forest species, but our adaptation now has taken us away from that, such that it's places that we don't live in high population densities that allows elephants to survive in those environments today. But you can see very clearly the effects of humans. If you look at the distribution of humans in Africa, or like the map I showed you in Asia, where humans are high population density, the elephants are gone. The elephants are now just existing in these pockets where you have low population densities of humans. Forest preserves are places where people just live at really low densities, or game parks.
And so our next question is about, do you think the current elephant habitat is due to domestication, and did or does domestication help preserve elephants?
The question was, is the current elephant habitat due to domestication, and does domestication help preserve elephants? So I presume that's a question about elephant domestication in Asia. That's an interesting question. I mean, in general, yeah, if something has an economic benefit, then there's interest in preserving it. So I think certainly that's the case in South Asia, that the use of, I don't think elephants are necessarily domesticated. I think they've been tamed, and they're ridden and used for hunting and for forestry purposes and things like that. Absolutely will help to conserve the species, but not in the wild state. In Africa, there is no domestication process of elephants, and there's constant conflict between humans and elephants. I mean, elephants are incredibly dangerous. They also destroy crops. They also compete with livestock. I mean, just like you can imagine ranchers in Wyoming and their conflict with wild ungulates here, those processes continue. Those processes are also true of elephants in Africa. But yeah, I think to some extent, the taming of elephants in Asia probably has helped conserve them a little bit. But the wild populations of elephants in Asia are highly, highly threatened at this point. I don't know if I answered your question.
I believe so. So my understanding is that around the time of the megafaunal extinction and the arrival of humans, there was also significant changes in vegetation and climate. And some researchers have drawn, have attributed not all of the extinction to humans, but have also attributed some of it to the changes in vegetation, which would not support large herbivores. Could you comment on that?
I'd be happy to. The question was about the possibility of climate and ecological change driving the extinction in North America. So 13,000 years ago in North America was a really busy time. The planet was coming out of an ice age. Glaciers were melting, sea levels were rising. Plant and animal communities were reorganizing. Atmospheric and oceanic circulation was changing. And on top of all of that ecological physiographic change, you introduce a highly efficient predator, humans, to the ecosystem. And sorting out causality of extinction has been incredibly complicated. And there are, I would say, there are many competing hypotheses. One is the overkill hypothesis that human hunting drove this extinction event. One is climate and ecological change. One is hyperdisease. This is the idea that humans brought with them, or possibly with their domestic dog, old world diseases to which new world animals had no immunity. And then another one is extraterrestrial impact, the idea that a comet or asteroid struck the new world and drove this extinction event. And first thing I should tell you is that none of these are mutually exclusive. They all could have happened. there is very little consensus as to what the major drivers of extinction are. I am skeptical of climate as a driver of extinction, if only because certainly climate was changing and changing dramatically, but we have to invoke climatic changes that will drive an extinction event over the scale of two continents, North and South America. And it's hard to imagine a unified climatic or ecological explanation to do that. Now, um, you'll hear interesting regional hypotheses. For example, we know that in the Southwest, like in Arizona and New Mexico in the Clovis time, Clovis people appear to show up in a drought. That marsh deposit I showed you is on top of the Clovis, it's just after it. But during Clovis period, we see, for example, people digging wells, we think deep pits to try to get to the water table. So if there was a drought in the Southwest at that time, we could imagine animal populations being severely impacted. Perhaps mammoths congregating around water holes or natural die-offs. But that's a very local phenomenon. We'd have to talk about a drought that covers two continents. And certainly at that time, there's no drought of that scale, say in the eastern woodlands or in Wyoming or in California or in the forests of Central America. So I have a hard time imagining a unified climatic explanation to drive an extinction event this large, this taxonomically diverse, and over this space. The one thing common to all of this space, in my opinion, is humans. But what the hyperdisease people will tell you is that, yeah, humans were certainly common to this, but it wasn't direct human impacts. It was indirect human impacts by bringing disease. It's very much a matter of scholarly debate, what drove this extinction event. I fall on the side of overkill, particularly when it comes to the proboscideans, because they're very susceptible to extinction with human hunting. And we have lots of evidence of human hunting of those animals. We have much less evidence of human hunting of other things that went extinct.
So is the future discovery of new sites simply a matter of chance, given how rare they are, or are there promising unexplored locales you would actually go to look to find new sites?
The question was, how do we find new sites in the future? Are there promising places where we haven't looked, or is it just a matter of chance? It's a really great question. As I mentioned, most of these sites aren't found by archaeologists, and they are found by accident. Found by people like Bishop or Heinrichs. The Lehner site was found by Ed Lehner, the landowner who found mammoth bones sticking out of a bank. If we were to systematically try to find these things, it would be incredibly difficult. The first thing you'd have to do is identify deposits of this age and where they are present, and then from there you'd have to identify likely places for archaeological sites, which you'd think we would have figured out by now. But they're remarkably difficult things to predict in terms of very specific locations. We can predict general areas where there should be a lot of sites, but to find the intersection of those things where you have terminal Pleistocene deposits and a Clovis occupation in them, nobody has ever been able to solve this problem yet. It's a needle in the haystack problem. That's a problem I'm really interested in, especially because if I want to continue doing Clovis archaeology, right, I don't want to have to depend on somebody walking into my office with a mammoth tooth. So yeah, there are places that really interest me in Wyoming that I think are likely to preserve deposits of this age and likely to have archaeology in them. So for example, I mentioned two mammoths here, the Lapel Mammoth and the Bishop Mammoth, both in tributaries of the North Platte River near Douglas. I actually know of 3 other mammoths also from tributaries of the North Platte River near Douglas. So what we know is that those streams that are joining the Platte and Converse County in that area tend to preserve sediments of the right age. We don't know how common archaeology is in them, but it really provides a rich area for looking for sites of this age. It's complicated though, because I can't just go out and look, right? A lot of this land is private land, so you need permission of the landowner. These sites are deeply buried. They don't have good surface exposure. So it's a complicated problem. So hopefully it's a nut we can crack with further work.
So my screen seems to have gone blank, so I can't see any other questions. maybe Brent or John, if you see any other questions, you can ask them.
No, all my questions have been asked.
Okay.
I see a question that says Colombian mammoth, sent to me privately. Colombian mammoth found in 1988 near Huntington, Utah, 9,000 feet elevation. Were there artifacts associated with it? I think I'm familiar with that locality. I think there was also a short-faced bear found there, and to my knowledge, there were no artifacts associated with it. Interestingly, there are no mammoths and mastodons in all of the Great Basin associated with human artifacts yet. The Great Basin, Utah and Nevada, is really devoid of this phenomenon yet. It's not clear why that is. But there are mammoths and mastodons from that area. And the idea of mammoths at 9,000 feet, yeah, that's, we know they were up in the mountains. There's a famous site that the Denver Museum was digging in snowmass. They call it snow mastodon, where they had a bunch of mastodon and sloth remains some fairly high elevation too. But those predated humans on the continent. The one in Utah, I think, was terminal Pleistocene. Any other questions?
Yeah, my screen came back, so I think we have you've answered everyone's questions. Todd, thank you for an absolutely fascinating talk. It would be amazing to walk into a place like Wyoming before any other people have been here. I'm sure you've thought that many times.
Absolutely.
Yeah.
Thank you for having me.
Thank you very much. Have a lobster for all of us. And next Tuesday, talk on otters, and then August 18th, digging dinosaurs in Idaho next door. And thank you, everyone, and good night.